In this example, for the function f of x equal x squared, use the definition of the derivative to show that f of 2 equal 4. So first we look at the function. So we have function of fx equal x squared. So since we are equating it to we use the first principles for the function where we're expressing equating it to 2. So we have the limit of h to 0, where function of 2 plus h minus f of 2 will be equated divided all by h, and then we will sub limit of h to 0, where we would have 2 plus h squared and take away 2 squared, all divided by h. So that will give us limit of h to 0, where it will be 4 plus 4h plus h squared minus 4 all over h, and then will give us the limit of h to 0, where it will be in this scenario the 4 with the minus 4 will disappear, so that will give us 4h plus h squared. So we can simplify that even further by taking a common factor of h, so that will give us 4 plus h in this scenario divided by h. The h will disappear, so we will have the limit of h to 0, it's 4 plus h. So in this scenario, as h gets closer to 0, then we would have 4 plus h will equal 4. So that proves to that then f of x or f of 2 equals 4, which is what we needed to prove. Now for part B, we have the function of minus 3 being equated to 6. So in this scenario, we are subbing minus 3 into the expression. So that will be minus 3 equal limit of h to 0, where it will be function of minus 3 plus h minus function of minus 3 all over h. And that will give us the limit of h to 0 being minus 3 plus h squared minus minus 3 squared over h. So in this scenario, we'll expand the expression. So we have the limit of h to 0 being a minus 3 squared. That will give us 9 minus 6h plus h squared minus 9. So plus 9 minus 9 will disappear, and also of course it's over h, so that will give us limit of h to 0 being minus 6h plus h squared over h. So that will give us the limit of h to 0. We can take the h as a common factor, so that will give us minus 6 plus h over h. The h from the numerator and the denominator will disappear, so that we will end up with h, when limit of h to 0 will be minus 6 plus h into brackets. So now as h gets closer to 0, we would have minus 6 plus h equated to minus 6. Then that will prove that f of minus 3 will give us minus 6 as the answer. And this will be our answer for parts A and B. In this example, we need to use the function of f of x squared, use the definition of the derivative to show that f of 0 will give us 0. So we'll start by subbing f of 0 into the limit of h to 0. So that will give us f of 0 plus h minus f of 0 over h. So that will give us limit of h to 0, where it is 0 plus h squared minus 0 squared over h. So that we will end up with limit of h to 0 being h squared over h. So that we will get rid of 1, so we will have limit of h to 0 being h. So that means if as we sub f of 0, it will give us 0, which is the answer that we need to prove. For part D, we have function of 50 equal 100. So in this scenario, we will sub the 50 into the expression. So instead of so we will have the function of 50 plus h minus the function of 50 over h, and this is within of course having the limits here, so that would be 50 and the limits here from h to 0. So now the limits from h to 0, it will be 50 plus h squared over minus 50 squared over h. So that will give us the limit of h to 0, where it is 2500 plus 100h plus h squared minus 2500 over h. So that 2500 with the minus 2500 would disappear, and we would have the limit from h to 0 being 100h, and we can take it as a common factor scenario. So we have 100 plus h over h, the h will disappear, so we got the limit from h to 0 being 100 plus h. So in the scenario, as h gets closer to 0, and 100 plus h will become 100. So in this scenario, f of 50 will equal 100, which is the answer that we needed to prove for this question. In this example, we have the function of f of x equal x squared, and we need to show that f of x of h to 0 is 2x plus h. So we will start by having for part A, f of x being the limit of h to 0, where the function will be f of x plus h minus f of x over h, which is the differentiation from first principles. So now we plug in lim of h of 0, where x plus h squared minus x squared over h, and now we'll try to simplify the expression. So that will give us x squared plus 2xh plus h squared minus x squared over h. The x squared with the x squared will disappear, so we would have the limit of h to 0, and we can take also h as a common factor, so that will give us x plus h over h, so the h will disappear, so that will give us the limit of h to 0 to x plus h. Now as h gets to 0, we have 2x plus h will give us 2x, so that will prove that f of x will be equivalent to 2x. So that will be a combination of this up to here is part A, and this answer, it will be the part B of the question, where f of x is equivalent to 2x, and this will be our answer for this question. In this example, the point A with coordinates -2 and -8 lies on the curve with equation y equal x cubed. At point A, the curve has gradient g. Show that g equal limit from h coming closer to 0, which is between brackets 12 minus 6h plus h squared. So first we will start with having the equation is x cubed, and the function of f of x will be x cubed. So now g will be limit from h to 0, where it is expressed in the form of -2 plus h cubed, as we sub the x value into the expression. As the differentiation from first principles, it will be x plus h minus f of x over h, and then when we sub the values, that will give us minus 2 plus h, and will be cubed minus f of x cubed, which is, in this scenario we are subbing minus 2, and then over minus 2 cubed over h. So now we will expand the expression, so that will give us minus 8 plus 3 multiplied by minus 2 squared h plus 3 minus 2 h squared plus h cubed plus 8 over h. So the negative h with plus h will disappear, plus 8 will disappear, and now that will give us the limit from h to 0 being minus 12h minus 6 in the scenario h squared plus h squared h cubed over h, and then we will take the limit from h to 0, where we take h as a common factor. 12 minus 6h plus h squared over h, the h's will disappear, so in this scenario we'll end up with the limit from h to 0, which is 12 minus 6h plus h squared, which will be the answer for part A that we needed to prove. For part B, deduce the value of g. So in this scenario we will need to prove that as h gets closer to 0, we would have 12 minus 6h plus h squared. It will be equivalent to 12, then g will be equivalent to 12, which will be the answer for part B. In this example, the point A with coordinates minus 1, 4 lies on the curve with equation y equal x cubed minus 5x. Point B also lies on the curve and has a x coordinate minus 1 plus h. So we need to, in the first part, we need to show that the gradient of the line segment AB is given by h squared minus 3h minus 2. So the first part, we will look at the y coordinate, where so the y coordinate in this scenario will be y coordinate of point B will be equivalent to minus 1 plus h cubed minus 5 minus 1 plus h. So the gradient of AB will be equivalent to y squared minus y1 over x squared minus y2 take away y1 over yx2 take away x1. So for us to create the gradient in this scenario, we would have minus 1 plus h cubed minus 5 minus 1 plus h minus 4, and all divided by minus 1 plus h minus 1, and in this scenario we'll try to simplify the expression to give us minus 1 plus 3h plus 3h squared plus h cubed, and then we would have plus 5 minus 5h minus 4, all divided by the minus h or plus h, so minus 1 will disappear, so minus 1 plus h plus 1, so this will disappear with the minus 1, and we also can simplify this expression further, so we have minus 1 plus 5 and minus 4. So in this scenario that should give us h, and we also have in this scenario we would have h cubed, so we'll just reorganize the equation. H cubed plus in here minus, so it should be minus 3h squared minus 2h over h, and then the next step will be taking a common factor, so it will be h squared minus 3h minus 2 over h, so the h will disappear from both sides, so that would give us h squared minus 3h minus 2, which is the answer for part A. For part B, we'll just explain that at point A, as h gets closer to 0, then h squared minus 3h minus 2 will get closer to -2, then the gradient equals -2, which will be the answer for part B.